Welcome to my channel, The Sake of Physics. Today I'm going to discuss significant figures. So what are significant figures? These are the figures which are reliably non-digits basically. What does it mean? That the number of digits about which we are reasonably sure are known as significant figures. So there are general rules we need to follow to write down a significant figure. So all digits are significant figures. However, zeros may or may not be significant. So a zero between two significant figures is itself significant. For example, if I write down a number like 101 or 4.03, then the zeros between two significant figures, they are also significant. But zeros to the left of significant figures are not significant. So none of the zeros in these numbers are significant. But zeros to the right of a significant figure may or may not be significant. What does it mean? It means that if the number is in a decimal fraction or a whole integer, for example, if we are given different numbers like 3.570 or any other number like 7.400, then these zeros are significant. But if we are given a whole integer, like mass of anything is given as 8,000 kilogram, then the number of significant figures in this digit depends on the least count of the scale with which we measure this mass. So if the least count is 1 kilogram, then the significant figures are 4 for this number, and we can write it down in scientific notation like this: 10 to the power 3 kilogram. But if the least count of the scale is 10 kilogram, for example, then we can write this number like 8.00 10 to the power 3 kilogram. So the significant figures will be 3 for this least count. Similarly, when a measurement is recorded in scientific notation or standard form, then the figures other than the powers of 10 are significant. For example, we are given a number like 8.70 times 10 to the power 4 kilogram. Then there are 3 significant figures. So it means we don't count this 10 to the power. So if we talk about multiplication and division of numbers, then we round the answer to the least number of significant figures in the problem. It means that if we are given certain numbers, like if I multiply two numbers and divide these numbers by another number, then the answer, then I'll get a very long answer like 1.45708 10 to the power 3. But here I can see that 3.64 has the least number of significant figures here. So I need to round this answer to the least significant figures here. So the answer will be 1.46. I need to follow the rules to rounding off here. So the answer will be 1.46 times 10 raised to the power 3. But if we talk about addition or subtraction of numbers, then we can say that In adding or subtracting numbers, the number of decimal places retained in the answer should be equal to the smallest number of decimal places in any of the quantities being added or subtracted. In this case, in the case of addition or subtraction, we can say that the number of significant figure is not important. It is only the position of the decimal which is important. For example, if we want to add these following quantities, um, I can write down the quantities with different decimal places, 3.42, and the other one, the last one is 0.003. The answer is 75.523. So here we need to see the least decimal position is for 72.1. So the answer will be 75.5. Similarly, if I talk about the subtraction, and if I'm given 88.9, and if I subtract 44.32, then I get here 44.58 answer. But the correct answer for this will be 44.6 if I follow the rules for rounding off. So these are the general rules we need to follow for the significant figures. So here I would like to do a simple exercise for different numbers. So exercise is, how many significant figures do each of the following numbers have? So the first one is very simple because there are no zeros and we know that all digits are significant figures. So it will have three significant figures. But if we see the second one, it has four significant figures. And the third one has three because zero is between two significant figures. And in this one, the none of the zeros on the left of the significant figures are significant. So we can say that it has only one significant figure. Similarly for this one, but here there are two significant figures. And this contains four significant figures. And this has two significant figures. And the last one has three significant figures. So this is just a simple exercise for looking for the number of significant figures for some numbers. Similarly, whenever we try to write an answer, we prefer to write it down in scientific notation. What does it mean? It means we write down answer in powers of 10, or scientific notation. So advantage for this is that we can be sure about the number of significant figures in the problem. So here is also a simple exercise I have for the scientific notation. If I would like to write it down, okay, so the very first number is already in scientific notation. This is a tricky one. So what we can do is, if we need to write it down like in the power of 10, then we can write down to the 10 to the power 0. And the second one is 2.18 times 10 raised to power 1. This one is 6.8 times 10 to the power minus 3. Here we can say that how much we moved here. So 1, 2, 3 from left to the right. And here we will move from right to left. So the power will be positive, and we move just one digit here, so it will be 2.7635 times 10 to the power 1. And here it is from left to right, only one digit, 2.18 times 10 raised to the power minus 1. And here it will become 3.33 times 10 raised to the power 2. And this one will become 5.6 times 10 raised to the power. So you can see that we are moving from left to right. 1, 2, 3, and 5. So it will be 1, 2, 3, 4, 5, -5, and this will become 2.69 times 10 to the power minus 2. So hopefully this will help you to understand the significant figure and also writing numbers in scientific notation. Please comment if you like this video and subscribe my channel if you didn't do yet. Thank you so much.